The Metabolic Trinity, understanding disease through glucose, glutamine, and glutamate. Good day, I'm Dr. Richard Nkwenti. Today, I'll be taking you through a fascinating journey into how three critical metabolites influence disease processes in our bodies. Imagine your body as a vast, interconnected city where every cell requires precise amounts of energy and resources to function correctly. At the heart of this cellular economy are three crucial players: glucose, glutamine, and glutamate. Let's begin with glucose, our body's primary energy currency. What many don't realize is that cancer cells have developed a particularly dangerous relationship with glucose. These cells exhibit what we call the Warburg effect, consuming glucose at rates up to 200 times higher than normal cells, even in the presence of oxygen. This isn't just excessive eating. It's a fundamental reprogramming of cellular metabolism that supports rapid growth and survival of cancer cells. High blood glucose levels don't just feed cancer cells. They can trigger a cascade of harmful events. They can induce oncogenic mutations, alter critical metabolic pathways, and lead to harmful protein modifications through a process we call OGLC acylation. Think of it as sugar molecules attaching themselves to proteins, disrupting their normal function and creating an environment where cancer cells can thrive. Now, while glucose gets most of the public attention, glutamine is the unsung hero, or in disease states, the hidden villain of cellular metabolism. Cancer cells become what we call glutamine addicted. They simply cannot survive without large amounts of this amino acid. It's fascinating how glutamine serves multiple critical functions. It's a nitrogen source for building DNA, a carbon source for energy production, and a key player in how cells respond to stress. When glutamine breaks down in our cells, it forms glutamate, and this is where our story takes another crucial turn. Glutamate is a critical neurotransmitter in our brains, but like many powerful tools, it can become toxic when present in excess. In neurological disorders like Alzheimer's disease, epilepsy, and stroke, glutamate dysregulation plays a significant role in causing cellular damage. The relationship between these three metabolites becomes even more intriguing in cancer progression. Cancer cells don't just use these molecules for energy, they reprogram their entire metabolism to extract maximum benefit from each one. They become more efficient at importing glucose and glutamine, and they alter how they process glutamate to support their rapid growth and spread. What makes these findings so exciting from a medical perspective is that they open up new possibilities for treatment. By understanding how cancer cells depend on these metabolites, we can develop targeted therapies that disrupt their energy supply. Some promising approaches include drugs that block glucose uptake, compounds that interfere with glutamine metabolism, and treatments that modulate glutamate signaling. While it would be an oversimplification to say these three metabolites are the sole cause of all diseases, they represent critical intervention points in treating various conditions. Think of them as key pressure points in the body's metabolic system. When we understand how to manipulate them effectively, we can develop more precise and effective treatments for cancer and other diseases. The implications of this research extend beyond cancer. Neurodegenerative diseases, metabolic disorders, and even some autoimmune conditions show distinct patterns of disruption in how these molecules are processed. By understanding these patterns, we're developing new therapeutic strategies that could potentially revolutionize how we treat these conditions. As we conclude, I want to emphasize that while glucose, glutamine, and glutamate play crucial roles in disease processes, they are also essential for normal cellular function. The key lies not in completely blocking these metabolites, but in understanding and carefully modulating their levels and usage in disease states. This understanding is opening new frontiers in medicine, leading us toward more effective and targeted treatments for some of our most challenging diseases. Thank you for your attention to this complex but fascinating aspect of cellular metabolism and disease. Understanding these relationships brings us one step closer to more effective treatments for cancer and other devastating diseases.